So evaluating exponential expressions. Here's the first one. Just use the rules, right? This is a to the m over a to the n, which is a to the m minus n. So we'll do that. We'll get 5 to the 2 minus 5, which is equal to 5 to the negative third. And we use this rule. The rule says that if we have a number raised to a negative exponent, it's the same as that number under 1 to that positive exponent, right? So this one, we should have taken this like this, flipped this thing over, and gotten 1 over 5 to the third. Somebody asked me the other day, they asked me if if they had just put 5 to the third, would that have been okay? But is that okay? 5 to the third, just to get an idea, 5 to the third power, so we're asking ourselves, is 5 to the third power the same as 5 to the negative third power? It's a question. 5 to the third power is 125. 5 to the negative third power is 1 over 125. So are these the same numbers? They're not even similar, are they? They're on kind of opposite ends in a weird way. This number is extremely close to 0, isn't it? How about at least comparative to 125, right? So they are not equal. And remember, you're supposed to cure negative exponents. Question 2 was 6 to the third times 6 to the 0 times 6 to the negative 5. What rule are we supposed to use here? X to the m times x to the n is equal to x to the m plus n. So that's what I'm going to do. This is 6 to the 3 plus 0 plus negative 5, which is 6 to the negative 2, which is equal to 1 over 6 squared. Answer. Good? The next one I think was even easier. I hope was even easier. And that one was 3/5 raised to the 4th power. So we got 3 over 5 raised to the 4th power. So in another class, they looked at this problem yesterday, and one of the students got an answer of, I'm not making fun of this person at all, it's not important who it was, but I want to know, what was this person thinking? I know that they were wrong, but what were they thinking? They said that, on their quiz, they said that 3/5 to the 4th power was 12/20. What did they do? They multiplied 3 times 4, and then they multiplied 5 times 4. Is that true? No. Exponents are distributable over multiplication, and division is a form of multiplication to me, so it's distributable here too. So this is equal to 3 to the 4th power over 5 to the 4th power, right? Good? All right. And what rule was that? That was this rule. A over b to the power of m is equal to a to the m over b to the m. Good enough? I'm just going to do this one last question because I think it's one that you're probably more interested in. This one right here. 2a to the 3rd b to the negative 4th over 3a to the 5th b to the negative 2. And I'm going to look at this way. Right, it's called decomposition, sometimes called partitioning. I'm just going to take this into its parts. I'm going to look at 2/3. Then after I look at the 2/3, I'm going to look at the a to the 3rd over a to the 5th. And lastly, b to the negative 4th over this. So let's do these one at a time. No sarcasm intended, but can we agree that 2 over 3 is still 2/3? Can't be simplified. So there's that 2/3. Then I'm going to look at this piece right here. A to the 3rd over a to the 5th, which is a to the 3 minus 5, otherwise known as a to the negative 2nd, otherwise known as 1 over a squared. So I'll put my a squared down here. If you want to put a multiplication sign and put a 1 there, it's fine. It's going to clean itself up later, so if that helps you to look at it. What about this? So we look at this problem. It's the same type of problem, isn't it? Tells us that we're supposed to do what? We have b to the negative 4, what? Minus negative 2, right? This part is formulaic. This negative sign right here, John, is formulaic. The pink one right here is from here, isn't it? So a negative negative is a positive. So we get b to the negative second, which is equal to 1 over b squared. So if you want to put a 1 over b squared here, but when you're done, you should have gotten 2 times 1 times 1 is 2 over 3a squared b squared. How you like that? Good? Good, good. Oh! You're sick, sick people. Thanks.